Okay, to Alpha, good afternoon. Can you hear my voice?
Can.
Yes.
Okay, okay, I hope you can hear my voice. Okay, what happened here? Still recording. Okay, nice. Right. And then also my presentation. Is it okay? Can you also able to see my presentation?
Can.
Can also, yeah? Okay, very good. All right. So, yesterday, we already finished buoyancy force. Let me open the textbook first. Force and motion. Okay. And then I ask you to finish the workbook page 104 to 105. This one. Okay. All right. You already finished this? You want to discuss the question or what? I think for today activity, I just discuss the question only lah. Yeah. Is it okay, right?
Yes.
Okay. So, experiment inquiry. We're supposed to have an experiment for this topic, yeah, but never mind. I just want you to refer to page 104, activity or experiment 8.4 about the buoyant force over here. Right? So you can open right now, or maybe later on lah. Maybe or if you cannot open right now, maybe later on after you see the video, so we can just find out the answer lah. Right. So again, this is how you want to determine the buoyant force by using a spring balance. Okay. So according to the diagram here, you must first, right? You must first what we call, where is the epic pen? Epic pen. Okay. So must have the two step over here. All right. First, you just tie a thread into the object that you want to measure their buoyant force. Okay. So first step over here. What happened? Okay. For the first step over here, you want to take the measurement. You want to take the reading from the spring balance, and then you we call it actual what class? Actual weight, actual weight from the spring balance outside the liquid. Okay. And then step number two, same apparatus. You just using the same object, you tie it to the spring balance, and then you take the second measurement when you put the object inside underwater, submerged inside the water. So you want to take their apparent what?
Spring
Apparent.
balance.
Yes, apparent weight. Okay. So there are two measurements here. The first, actual weight outside the liquid, and then number two, the apparent weight. The apparent weight, to take the measurement from the spring balance after you put the object inside the water. And then there is a what we call different. Yeah, there is a different with the reading in step number one and step number two. And usually the reading of spring balance in step number two is usually less than the actual weight. So that's how you want to take the buoyant force. Okay. And then the formula, you just minus the actual weight minus the apparent weight. Okay, this is how you want to take the force. This is how you want to determine the buoyant force of a liquid. Okay, by using this activity. Right. So next one. Okay. So I think for this, you just take the value here. Just take the value. All right. Just take the value. Plasticine. What happened to the plasticine? It will sink. Okay. Actual weight 4 Newton. Apparent weight 3 Newton. And then the buoyant force is 1 Newton. Okay. This is for plasticine. And then for the wooden cube, what happened to the wooden cube? It will float. And then the actual weight is 2 Newton. The apparent weight is 0. So the buoyant force is 2.0. Like I said earlier, we should be doing this activity in the lab. But never mind. I hope you try to understand the concept. I hope you try to understand how the step to measure the buoyant force by using an object, by using a spring balance, and then you just submerge it inside the water, and then you take the measurement and calculate the buoyant force. All right. So this one is actually you just copy this inside your workbook. Yeah. Plasticine usually it will sink, wooden cube is float, and the rest of the value. All right. Later on, yeah. Okay, never mind. Later on, I will, if you, I will give you the record or the result later. Yeah. Okay. Next one. Discussion number 1. Okay. What happened if the buoyant force is? Okay. What happened if the buoyant force is equal to the weight? Equals to the weight. So what happened to the object? The object float on the water. Okay. B, smaller than the weight, the object sink in the water. Okay. Number 2, identify whether it is an action force or reaction force. Okay. For A, it is action force, and then for B, it is a reaction force. A is action force, B is reaction force. Right? Okay, next one, page 105. Okay. Based on the result of this activity, explain the buoyancy. Based on the result of this activity, explain the buoyancy of object in water. Choose the correct answer. All right. If is object float, an object will float if the buoyant force is equal to the weight of the object. Okay. The object will float if the buoyant force is equal to the weight of an object. On the other hand, object will sink if the buoyant force is less than the weight of the object. If the buoyant force is less than weight of the object, so it will sink. All right. If the buoyant force is equal to the weight of the object, it will float. Okay. For example, like this, is I have a inside the water, inside a beaker, for example, I have a beaker here, and then inside the beaker, I have a water. So inside we have water. Happen to the pen here. Okay, we have water over here. We have water. All right. And then this is the object. This is the object over here. Right. This is an object. Right. So what is the force acting on the object by the red line over here? What are the force here?
Buoyant force.
Okay, very good. This is buoyant force. And then what are the object from the above? Exert from the object. This is what force?
With.
This is the
With.
weight. Okay, this is the weight of the object. Okay. So if you look at the textbook, what are the okay, F, this is buoyant force. We write it as F, okay, and then this we write it as W. All right. So what is the formula? What are the what we call difference? Right. If F force is more than weight, so the object will float. F is more than the buoyant force is more than weight, so it will float. The buoyant force again, the buoyant force F, this one, F, if more than weight, so the object will float. Right? So this is W. W is the weight. Right? This is W, weight. Okay? You can refer back to your textbook lah, page 179. Okay? Another one, if the force in opposite class, if the force, let me draw it this over here. If the force, the buoyant force, more than or what? If the force is less than the weight, the object will sink. Okay, right? Can you understand this? If the force meaning that the buoyant force is more than weight, so the object will float. If the buoyant force is less than weight, the object will sink. Right? The object will sink. Okay? You just refer back to the textbook, page 179 to 180. Okay? Right. Again, number 3, the answer is equal to and then less. These are the answer for question number 3 on your workbook. Okay? Okay, we go to question number 4. Explain the difference between the density and the buoyant of an object. Okay. When an object is less dense than liquid, the buoyant force will be greater than the weight. If the object is less dense than liquid, the buoyant force that is greater than the weight push the object upwards. The less dense object, less dense than liquid, the buoyant force that is greater than the object push the object upward, and then the object will float. On the other hand, when the object is denser than liquid, the buoyant force is less than the weight of the object, and then cause the object to sink at the bottom of the liquid. For example, like here, all right, why the object here float? Because the buoyant force is more than the weight, number 1. I will erase this first. Because why? Because the force, sorry, not the force, the buoyant force. F is the buoyant force. The buoyant force is more or great than weight. The buoyant force is more than weight, so the object will float. Object will float. It will object float. Number one. Okay. And number two, the density. If the density of object, right, is less than density of liquid, what happened to the object? Float or sink? It also, class number two, density of object is less than the density of the liquid. It also will be float or sink?
Float.
It also float. Okay, right? Because when the density of object is less, the buoyant force is more. The buoyant force is more. All right, that's why the object will float. That is the relationship between the buoyant force and liquid. Okay, the density of object less than water than liquid. At the same time, the buoyant force is more than the weight, so the object will float. Okay, and then vice versa. Vice versa meaning that in opposite also like that. Okay, if the density, for example, the opposite of this explanation, if the density of object is more than the density of liquid, the object will sink. When the density of the object is more than density of the liquid, right? The buoyant force is also less than the buoyant force is also less than the weight, so the object will sink. You just explain the opposite only, right? Okay. Okay. Right. When the object is denser than the liquid, the buoyant force is less than the weight, cause the object to sink at the bottom of the liquid. Yeah. Okay. Number 5. This is plimsoll line. I already explained you about the plimsoll line. Okay. So cargo ship marks with the plimsoll line for safety purposes. The plimsoll lines help to determine the safe level of the cargo ship to float in the ocean with different temperature, salt concentration, and density of seawater. Okay, so this is what we call the ship use the plimsoll line to determine the safety level for the ship to sail on the sea. Consists of 3 conditions: the temperature of the water, the salt of the water, salt concentration, and the density of the seawater. You still remember this one? You still remember this one? You still remember the picture here? Right? So, if the density is more, for example, if the ship here traveling on the ocean, okay, it will float a bit because the density of the water is more. The cargo ship will float a bit with the same weight. For example, with the same weight, the weight of the ship over here is about maybe 1,000 ton. This is also 1,000 ton. 1,000 ton. Okay. Same weight of the ship, but if the what we call the density of the water is different, so it will either float a bit or sink a bit. For example, in ocean water, because the density of water is more than fresh water, the ship over here will float a bit. You can see here. I can see here, right? It will float a bit. When in fresh water, it will sink a bit. That's why you cannot. That's why it is for the safety purpose lah. Okay. Maybe. Never mind. Later I will explain. Right. So you cannot. What we call put the cargo inside the ship too much. If you want to sail. If you want to sail the ship in the fresh water or in a river, because the added weight will make the ship more sink. That's why very dangerous lah. If the ship is heavier, so the ship maybe can sink at the bottom of the river lah. Can you understand this? Boleh ini ya?
Can.
It's okay? Okay. Never mind. All right. So, 105, the conclusion, buoyant force is the difference between the actual weight and the apparent weight. Right? So, this is the discussion on a workbook exercise question, page 104 and 105. Okay? Do you want to end the class right now? I think I will end the class right now. We will continue tomorrow. Next topic in chapter 8, that is lever. Is it okay, class? Lever, tomorrow lah. I continue. I will start the class tomorrow at maybe 10, not 10, 11 in the morning. Is it okay? Tomorrow?
Okay.
Okay. Okay, very good. I don't want to make the online very long. Maybe 30 minutes or 25 minutes only. Okay, I don't want to. I don't want to make the class too long for GM, for Google Meet online, right? So I will meet you all again tomorrow at 11 in the morning. If you have any question, you can ask me also. So we end the class right now. You can leave the class now. Thank you very much. See you all tomorrow. Bye-bye.
Thank you, teacher.
Yes, thank you very much. Thank you very much.
Thank you, teacher.
Yeah, thank you very much, Wei Xiang. Thank you.